All right, page 564 in your textbooks. I want to quickly review some things with you that we've been talking about the last couple of days, but we have had a weekend off here. So we've been talking about the study of collecting and organizing and analyzing and categorizing information class, specifically numerical data. We call this statistics. Statistics, two types of statistics. One type of statistics just tells you what the facts are. You know, there are 7 people in this room. What conclusion do I make? I don't know. I don't care. There's 7 people in the room. That's just what we want to know. A daily attendance, right? Okay. What type of statistics just states what the facts are, class? Descriptive. As opposed to the type of statistics in which we look at the results and we draw conclusions from it. Oh, 7 students. Well, that means that every student gets a lot of individual attention and they get called on a lot and they can't get away with sleeping in class because the teacher is ever watchful over all 7 of them because there's so few. Okay, that would be, class, inferential statistics. So the two types of statistics are descriptive and inferential. The entire group that is being studied in a statistical study is referred to, class, as the population. But since we rarely study the whole group, other than maybe a census in which everybody's supposed to be accounted for, if we just take, 1,000 people and get that, or I was recently looking at something on the news where they had a study that had come out, well, they're just polling a small group of people. That group of people, class, is called the sample, and the sample size is represented by the letter N. The thing that we're studying is referred to, Kendall, as the... Somebody's speakerphone is very loud on the other side of the wall. Sorry, tune that out, Kendall. The thing we want to know, the question we're asking, how many kids in the room, how much money people make, questions like that. That's the variable. Good. And we said that there are different types of variables. For instance, if variables are numerical, right? How much money people make, how many people in a room, class, that's called quantitative. But if we were trying to assess other things, for instance, we wanted to know... people's favorite foods. Well, that's not a number, class. That would be qualitative and quantitative, two types of variables. Now, for quantitative variables, we said sometimes variables can be counted. 1, 2, 3, 4, 5, 6, 7 people in the room. Class, that's a discrete quantitative variable. But if we tried to figure your heights, to figure, what the normal height is in this classroom, we would have, by the way, Kendall. Kendall's height is very different from the rest of our heights. She's special in that regard. She's my favorite in that regard. Class, we would describe any quantity or value that is far from the rest of the data set as being an outlier, right? Kendall would be our outlier at right around 4 feet. Is that right?
4'9".
4'9". Okay, never mind. I didn't mean to insult. 4'9". Picking on Kendall there. Anyway, the rest of us are all over 5 feet, and some of us are well over 5 feet. Anyway, you over 6 foot? Almost 6 foot. So you're kind of like me. You're like, you want to claim that 6 foot. You're like, with shoes,
The doctor says I'm 6 foot, but they lie a lot.
They lie? Okay. Well, anyway, if the doctor says it, name it and claim it. That's what I say. But anyway, value variables that would have to be measured, class, are continuous variables. So you count it, discrete, you measure it, continuous. And those only are quantitative variables. We talked about finding what's normal for a group of data, right? What's the normal height here? And when we talk about what's normal, we're talking about one of our 3 measures of center. There are 3 measures of center. One of them is literally the average of all of our heights. We just average them together. And what's that called? Also what I was being to Kendall a moment ago. Mean, very good. How do we represent mean, Mr. Nadowski? No, how do we represent mean, Maddie? X bar, and we saw that in some formulas yet in our last lesson. Another way to find measures of center would be to put all the data in order, which we call ranking the data, and we literally just kind of work our way and find the middle value, or if there's 2, we could find the mean or the average of those 2. That's the median. So the mean, class, is the average. The median is in the middle of a ranked data set. How do we represent median? Class? Capital M. The other way is just to find the number that keeps coming up. We keep coming up with 5 foot 7 inches. Everybody seems to be 5 foot 7 inches. Okay, well, a bunch of people were 5'7". Out of 7 of you, I don't know. Anyone in here actually 5'7"? Only Abby. All right. 5'6"? 5'5.5". Let's call you 5'6". 5'6"? 5'8"?
No.
5'9"? You're not that tall. You're taller than Abby.
Yeah.
Really? I don't know, maybe it's the hair. No, we won't stand up and measure right now. We don't have time for that. It's a short class today. But the number that occurs most often is the mode. The mode. I kind of bet all three of you. Matter, you're not 5'7" either. 5'6"? Okay. All right. I was like, I think any of them could be 5. I know you're a little shorter than that. Obviously, you're 6 foot. And there's Kendall. Anyway. Now, we talked about outliers, and we said if there are outliers present, which we have in this class, right? And we love our outlier, don't we? Yes, everybody nod your head. But if we have outliers present, we wouldn't want to go, class, with the mean as our measure of center. We would want to use the median as the measure of center that shows what's normal, because outliers affect the average, but they don't really affect the median in the same way. If we were to measure the difference from the tallest and the smallest, who happen to be sitting right one in front of the other, and aren't you glad we didn't put smallest behind tallest? Then you wouldn't be able to see. Oh, you'd like that. Anyway, but if we found the difference between the tallest and smallest, or the biggest and smallest values in a data set class, that's called the range. And the range also indicates a large dispersion or a large distribution in the data. Now, our whole lesson last time was about different ways to measure distribution of data and ways to show how varied the data is, how much variation there is. One of the measures we talked about found the average difference of every value in the mean. So we figure what the average was of the class. We measure Kendall's difference from the average, Michael's distance from the average, Genesis, and so forth. And we take all these distances from the average, their absolute values, and we would add them all together and divide by how many there were. We'd find the average distance from the average. What term describes the average difference between each value and the mean? Anyone? Something deviation, not standard deviation. Mean deviation. It shows the deviation from the mean. Okay, so mean deviation is average difference of each value. What we said we would do to find mean deviation, remember, is we take the sum of all the values difference from the mean and divide by how many there were. Okay, so that was mean deviation, average difference. But the problem was we said that values that are a lot away from the mean get offset by values that are a little different from the mean, and it all kind of comes out in the wash. But values that are a lot different from the mean should be represented. They should get prominence because they're way different, right? They're more like outliers. So to emphasize outliers, we took something that involved squaring all of these differences. And then to offset that, smarty pant mathematicians said we're going to divide by n minus 1 instead of by n. When we take the squared differences, that gave us something called variance. It was represented by the letter S squared, just to point out that we're squaring stuff. That was the variance. But we said, we get such enormous values, that seems ridiculous. So then we said, well, let's take the square root of all of this, and we'll represent it by the letter S, or sometimes by the Greek letter sigma. And this is really the best way to show variation in a data set. This is called, class, standard deviation. It's the square root of the variance. So class, if we're just finding the average difference of values from the mean, that's mean deviation. If we use squares to express deviation, variance, if we take the square root of the variance, standard deviation. And on your calculator, we had, of course, that button. It was the sigma xn minus 1. It was actually right above the square root button on your calculator once we entered statistical mode. And you two were assigned to figure it out via YouTube. Did you figure out how to do it? So you're both good. You don't have to do any crazy formulas, bless your heart. You're able to just type in the numbers and hit a button, and it does it all for you. That is wonderful news. Let's take a look at the homework. And actually, I think what I'll do is I'm going to save the page 564, 5 through 12 for the next lesson. So don't lose that homework, the 5 through 12 you did. But let's flip back to page 563 for sake of time. And let's take a look at the actual stuff we've been working on lately. Because factoring is great review for the exam, but we can do that tomorrow. Right now, we need to make sure we have a good handle on statistics. You did numbers 1 through 4, finding the mean, median, mode, range, and standard deviation. Number 1, read the problem for us, if you would. Maddie.
There were the following numbers of hours per week for the past several weeks: 40, 32, 50, 40, 40, 38, 41.
All right, so we were supposed to find, first of all, the mode. Was there a number that just kept appearing multiple times, Maddie? 40 is clearly the mode, and it is unimodal. The next thing was the median. Well, when we put them in order and found the middle value, what was that middle value? Genesis? 40 again, happened to be the middle value. When we averaged all these numbers together, what was that average or the mean, Audrey? 40.143. Do you see that all the measures of center are coming out to pretty much 40? So a normal work week is easily 40 for her. Were there any outliers, by the way? I mean, you could kind of say 50 and 32 were kind of outliers, right? I mean, they're kind of a big gap, but they were kind of the same gapness on both sides, so they kind of offset. But it does give you a fairly large range, right? You'd normally think, okay, 40-hour a week, there'd be a small range. Well, it's a fairly large range. They just happen to offset, so the mean comes out normal. What was that range, Brandon? 18. And then the standard deviation, when you plugged in all the numbers, remember on this calculator, you'll plug in the numbers, you'll keep hitting sigma plus after each number, and then to find the mean, of course, you can just do the x bar, which is above the x squared. To find standard deviation, it's above the square root. What was that standard deviation, Michael?
4.911.
That is not what I had. Kendall, what did you have?
5.305.
I had 5.305. What did you have, Maddie?
4.911.
You had 4.911 also. Okay, you both did the same thing on the calculator, right? Because you have the same calculator. You looked it up. So something maybe not correct. Okay, we'll look at the next four. If we don't have it figured out by those, we'll figure out what we need to do here. It should have been 5.305 for that standard deviation. Questions on number one? Let's go to number two, Leonard's history quizzes. There's only 6 of them. What is the mode here? Back to Maddie. 100 is the mode. That's not his average, unfortunately, but you know he's good for 100s most of the time. What is the median, Michael?
97.5.
Yeah, it's in between the 95 and 100, so we'll average those two values, get 97.5. What about his actual average, his grade book average? X bar, once you type all the numbers into the calculator. Kendall?
96.667.
96.667, and then what do you get for the standard deviation, Audrey?
8.165.
Ooh, that is not what I had. Genesis?
29.6.
That is, oh, the range was actually the next thing I was supposed to ask. I just skipped over the range. What is the range, class? 10. Okay, standard deviation. Brandon?
I ran the 2 decimals, 4.08.
Yeah, I did 3 decimals, 4.082. How many have the 4.082? All right, those with the calculator like mine, this is an easy data set to do because there's only 6 numbers. So the first number we would normally type is the 90, and remember hit sigma plus. Then 95 sigma plus, 95 sigma plus again, 100 sigma plus, 100 sigma plus, 100 sigma plus. So you got 6 values in the calculator, n equals 6. Again, second function x squared, or x bar, gives you the average, 96.66666 and so forth. Second function square root, or sigma xn minus 1, is your standard deviation, and that's 4.082. What did you get for your standard deviation?
8.727.
I know.
Yes. Yeah, I know what you're doing as well. You're finding a deviation of population as opposed to sample.
Because we don't know the symbols on our calculator for standard, because the video I think that we both used is different. And he had different symbols on it, but it was the same calculator.
Really? But it had different symbols than you have. Because sigma x is, the number 3 is what it would be. So I'm curious about, try number 4 instead of number 3.
4 was what gave me the 5.304.
Okay,
So
yeah, so you figured it out then. So when you go to your statistics, instead of selecting option 3, which is sigma x, you're going to choose SX. Because sigma x is actually truly population sample, or is population standard deviation. We're going with sample standard deviation, which is this one. So SX as opposed to sigma x. You guys, your difference is, by the way, do you all see above the division key, you have sigma xn? This is what they were using, was this value. We're going with sigma xn minus 1, which should have gotten us the 4.082. How many have on your calculator now the 4.082? Anyone still struggling to get that? All right. I'm confused. All right, so go do, hold on. Second. Oh, you've only got 5 values entered. That's why. Yes, you need to put one more value. I think, have you been putting them in this order? Maybe you missed 100. I've got 6. Your X bar is wrong, so no, that's not what it was. Okay, so start over, we'll turn off and turn back on. Re-enter the numbers very quickly. 100, sigma plus. 95, sigma plus. 90, sigma plus. 100, sigma plus. Another 100, sigma plus, and then 95. All right, Maddie and Michael, you both have it now. Perfect. Okay, so great, we figured it out. Just took a little bit longer than we wanted to. And then
You gotta press the sigma plus after the last number.
every number as you enter it, the sigma plus is what puts it in the set. Okay, tell you what, let's do this on the next one. Or actually number 4, I'll have you re-enter it because there's not too many numbers there, but we do want to move on. Number 3, a church had a certain number of attendees in the set for several weeks. It lists them all out there. Number 3, what was your mode, Abby?
None.
There really wasn't a mode. No value repeated itself at all, so definitely no mode. What about your median, when you ranked them in order and got that middle number? Genesis? Your median. 92.5. What about the mean? Again, this is where you put in the calculator and use X bar, Kendall.
92.1.
92.1. The range, all you have to do is subtract biggest and smallest. What do you get, Michael?
59.
59. And then for the standard deviation, tell you what, let's go and plug in the numbers in the calculator again if we need to. Should have got 19.267. How many had the 19.267? Okay, several of you. Okay, those who didn't, retype the numbers into the calculator and use that sigma xn minus 1. Again, so that statistical mode is good for both average and standard deviation. 19.267? Okay, so re-enter again. Let me watch. Who else didn't have their hand up a moment ago? Audrey, you're re-entering right now. Okay. Oh, not pi, sigma plus. Oh, those nails though. They look slightly dangerous and bad for calculators. Moral of the story, if you get an office job, you don't get to do the fake nail. Or pencil, there we go. Plus. $91. And that's it. Okay, so second X bar, there's the average, second, and there's your standard deviation.
I was hitting the division one because when you guys said
Right, that's the wrong one. That's the other one. Yeah, so sigma xn minus 1. All right, and you've got it now? All right, so number 4, the mode should have been 64. That stood out. 65.5, the median. 71.25, the mean. The range, 42. And the standard deviation, 13.926. Anyone perfect on number 4? You got all the answers. Anyone just missed the standard deviation? You got the other ones, but we know how to do it now. All right, let's practice with a couple more then. Do just in the previous section, number 3, the shoe salesman. So page 563 in the practice now, number 3. And again, we're going to ignore their instructions. We're going to do what we just did. We're going to find the mode, the median, the mean, the range, and the standard deviation. Not that the median, calculator can't give you a median, but you don't need it for that. Number 3 with the shoe salesman. If you're good on 3, go on to 5. If you're good on 3, go on to 5, but check your answers first. If you have any questions, now's the time to get them cleared up. By the way, not much difference here, right? Not any real outliers here. So the mean is really the best measure of center to use. No real outliers, very small standard deviation. If you're good on 3, go on to 5. If you aren't good on 3, get your question answered. I'll come to you and help you personally. In fact, if you're watching on YouTube and you don't have this, pause the video, wait till I've had a chance to help you through video chat before you try to go on and even do number 5. No sense persisting in wrong methods. Really close. You have all the numbers.
Yeah, I have something.
So you got it all up to 94. 4, 5, 5, 6, 6, 8, 9, 10. I wonder if maybe just hit a mistype somewhere. Oh, I missed a 5. There's another 6. Okay. Oh. I must type something in. One more time, you do this stuff. I'll watch. It's 4, 5, 5, 5, 6, 6, 8, 9, 10, another 10, 12, 14.
I'm getting something different for the mean too.
We go. I'm getting 7.83 repeating.
Okay, so maybe my numbers are off, all right.
And then,
Number of you getting different values.
3.186.
yeah.
Okay,
Standard deviation.
let me redo this. 4, 5, 5, 5, 6, 6, 8, 9. Wonder if I just did a keystroke here. 10, 10, 12, 14. I got 7.833 now. And a standard deviation of 3.186. All right, we like that number better. Okay, so if you paused the video and got all that help and found out I had the wrong answers. All right, lovely. There we go. I wonder what I mistyped then. All right, there we go. Questions? All right, going to number 5. I love it. I love it. Oh boy, a small data set. I like small data sets. See, small is good, right, Kendall? I like those numbers better. The mode is rarely the best measure of center. Usually it comes down to one of these two. Which one is my goal to use as the normal class? Which one?
Mean.
The mean, right? I'd normally like to say the average is normal. The only reason I wouldn't use the mean is if there is an outlier or a couple of outliers, right? Outliers are going to mess things up. In that case, I would default to the median. Do we have any outliers? No. Pretty evenly distributed here. Small standard deviation. So here we'd say what's normal would be 12. What's normal would be 12. Questions on this? Any questions on what we've done with statistics? Maybe some of the terms we talked about earlier, mean, median, mode, standard deviation. Again, that's really the only thing most people use now, but I wanted to show that progression in the last lesson. Any questions before we take our last quiz of the school year? Any questions? Going once on questions. Going twice. Come on, clear that. 6 at 4. A clean sheet of paper, a pencil, and definitely the calculator. Turn it off, turn it back on again to make sure that your statistical mode is cleared and ready to use. Make sure you clear out that statistics mode. There's no sense accidentally having old stats stuck in there, so turn it off, turn it on again. That way you clear the statistics out that we were just using. Clean sheet of paper, pencil, calculator. First last name at the top of your paper along with today's date, which is 5/16/22. 5/16/22, today's date. 5/16/22, today's date. Throwing the quiz to Brandon on the floor. Get down on the floor and grovel. All right, let's take a look at the quiz together. First section is a matching section. Choose the letter of the term on the right that best matches the definition or description on the left. Answers may be used once, more than once, or not at all. Notice that the answers in the answer column are alphabetical, so that should help you find things more quickly. All right, but just writing the letter for 1 through 15, that's matching all of those terms. Then problem 16 has lots of different parts to it. Okay, so let's take a look here. There's a church GoFundMe page. Here's the first 11 donations that came in that first week. You're going to find letter A, the mean, B, the median, C, the mode, D, the range, E, the standard deviation. Then you're going to name what letter F, what is the population, what is the sample, and what's the variable. Letter I, how much has the church collected so far? Now, for that, look above the open parenthesis button on your calculator. The sigma x, remember that's the sum of all the values. Assuming you've already put the values into the calculator, just hitting that should give you the sum. All right, so don't clear the calculator after part E. Then letter J, you're going to tell me the mean, the median, or mode, which is the best one to use to describe what's normal for a person to give. And then letter K kind of builds. What if 200 more people all donate the normal amount? What's the total collection? All right, so 16 kind of is a big multi-part problem. Do the matching, and then the problem. There will be no homework this evening, just to bring back what we did in the other lesson that we haven't gone over yet. You may begin.